This video is Unit 11, examples 2 and 3. So in the packet we show how to do this with the TI calculator, and so in this video I'll show how we can do the chi-square test on StatCrunch. So example 2 gives us a list of births by day of week for New Jersey for a whole year, and we want to know if the births are evenly distributed by day or not. So we're trying to figure out, is there a difference in the proportions? And this is 7 different proportions we're comparing, so we can't just do our usual 2 proportion comparison, so we go to this chi-squared test that you've read about. So in StatCrunch, we input the number of births by day in one column, and then the expected births are found by taking the total and dividing by the 7 days. So if the births are equally distributed across each day, we'd have 16,689 births per day. And then to do the chi-square test, we go to Stat, and we're going to do the chi-square goodness of fit. So this is under goodness of fit, and we choose the chi-squared test. And then we have to first select our observed column. That's the number of births in New York, and our expected column is called expected births. You could also check all cells in equal proportion. That would work in this case. And then we'll go ahead and ask this to compute for us. And we see here we've got a very small p-value and a high chi-squared value. So the high chi-squared value tells us that these results would be far out if they were actually equal. The 6 degrees of freedom are because we have 7 proportions here, and the degrees of freedom are 1 less than the total categories we're looking at. And here is the observed and expected values that we had. So here we're able to conclude that there is sufficient evidence to reject the claim that births are evenly distributed across the 7 days of the week. And so we say there is some sort of significant difference. Let's go look at example 3. So if we head over to example 3 in our packet, we see that's about jurors in Alameda County, and this is actually a famous case. So it was a study of grand juries in Alameda County, and they found that the number of jurors in each age group was different than the countywide percentages. So we want to know, are these differences significantly different, or could they be reasonable differences if the jurors are in fact representative? So in this case, the countywide percentages are what we expect. So those are going to be our expected column, and the number of jurors are going to be the observed data. We can't just equally add up the jurors and divide, because when we look at the county percentages, we see Alameda County at this time had much more people in the 18 to 40 age group than in the other age groups. So we have to use the countywide percentages as the expected values. So our claim is that jurors are evenly distributed according to the countywide percentages. That's the null claim. And so our null hypothesis would be that proportion 1 equals proportion 2 equals proportion 3 equals proportion 4, where the proportions correspond with the different age groups. And the alternative hypothesis is saying at least one of the proportions is not equal. So if we go over to StatCrunch, I've typed in the countywide percentages in a column and the number of jurors in another. And again, we'll go to Stat, goodness of fit, choose the chi-squared test, and then our observed column is the number of jurors, and our expected is the countywide percentage. And then we can go ahead and say compute, and we get a very small p-value, and our chi-square is 61. And so for 4 different proportions, this is considered a significant chi-square value. The degrees of freedom is 3 because we are looking at 4 different proportion groups, and so the 4 groups subtract 1 gives us 3 degrees of freedom, and our n is 66 jurors total were in the observed values. So again, we see a significant difference, so this would warrant rejection of the null hypothesis, and we could say at least one of these proportions is not equal.